So next part is student battery. Okay, this is the last part of the electrochemistry. So battery means it is the connection of more than one cells. Okay, so when more than one cells are when we are connected like in a series, then it is called a battery. Okay, so batteries are example of what? Galvanic cell or electrolytic cell. These are example of both galvanic cell as well as electrolytic cell. Okay, so these batteries are actually it is of how many types? Batteries are of two types. Okay, suppose mobile battery we are using. Yes or no? Wristwatch battery we are using. Camera battery we are using. Yes or no? Video game battery we are using. Then car battery, bus, truck battery. So different types of battery we are using. So these batteries are of actually two types. One is called a primary cell and another one is called a secondary cell. Primary cell and a secondary cell. So first we will read what is primary cell. Primary cell means the cell which cannot be rechargeable. The cell can only used once. This is called primary cell. But secondary cell means the cell which can be rechargeable by again and again. This is called a secondary cell. Okay. So first we will read what is primary cell. So primary cell, the cell which cannot be recharged or the cell which cannot be reused. So the primary cell, there are two types of examples. One example, this is called a dry cell or a Leclanche cell, and another one is button cell or a mercury cell. So in the dry cell or in the Leclanche cell, suppose this is an example of a dry cell, yes or no? So here you see, in this dry cell, the outer part is actually zinc, which one is act as anode. Okay, outside part, because the outside part over zinc you see that every company what one paper or polythene is pasted. Okay, so outside container is zinc, which one is anode, and inside this one graphite rod is present or carbon rod is present, which one is act as cathode. And this graphite rod, it is surrounded with carbon powder and MnO2, manganese dioxide. Okay, and which type this part is filled with what? Filled with ammonium chloride and ZnCl2, which is act as electrolyte. Clear? So this electrode act as positive, this act as negative, and the battery which is available in our market, you see here outside part like this, here you see, yes or no? This is what filled with the paste, and here above this one cap is there. So here in the this cap you see, here it is written positive and here the outside is what? Negative. And in this cell, the potential difference is 1.5 volt. 1.5 volt. So this reaction is not what? Reversible. So you see, anode zinc loses electron. So Zn2 plus 2e. At cathode MnO2. Yes or no? This ammonium ion gain electron. It gives manganese oxide or hydroxide plus ammonia gas. Understood? So this is the dry cell reaction, anode reaction, cathode reaction, which are electrolyte, electrode, positive, outside negative, potential difference is 1.5 volt. Clear? So sometimes in the exam questions are coming, why the dry cell, if only used once also the cell become dead. Once means, suppose if you take this battery or cell, okay, so in the torchlight, suppose if you put only once and after what, giving or pressing only one time switch, so the torchlight will glow, then what, you make it like this, means switch on. So if you keep it 15 days or after 30 days, the cell become dead. We are not using, but cell still become what? Dead. So why? Because in the overall reaction, you see the ions are taking part. In the overall cell reaction, the ions are taking part whose concentration may change. So that's why the cell is what? Not rechargeable, and second one is only after once also if you use, after some time or few days also the cell become dead. Clear now? Then another part, the important part you will remember, that produced ammonia gas, this produced ammonia gas, it react with Zn2 plus, it forms some complex. You know, suppose this is the normal you see everyday battery, but in torchlight there is a little what, little big and a little what, thick. Yes or no? And after 10-15 days or in this rainy season, after sometimes some white part will what, produced in the side by this zinc. So what are those, this white compound? Yes or no? So these are actually that complex. So this which type of compound you see? So produced ammonia gas, it react with this Zn2 plus, it forms some complex. Okay, the complex is Zn NH3 whole 4 square bracket some plus. Okay, Zn is 2 plus. So this type of a complex will form. Understood? So again I am explaining. You see, so in the dry cell or in the Leclanche cell, anode is a zinc container, cathode is a carbon graphite. So at anode zinc loses electron, at cathode manganese dioxide plus ammonium ion, yes or no, it what, gain electron. Okay, potential difference is 1.5 volt, it cannot be what, recharged. Okay, after only using once also the cell become dead. Why? In the overall cell reaction, ions are taking part whose concentrations are decreasing. Clear? This is one cell. Similarly, second one is button cell or mercury cell. Button cell or mercury cell, in the wristwatch we are using that small cell. Button cell, button not mutton, button cell or which is called a mercury cell. So in the button or mercury cell, you see zinc amalgam, when it react with OH minus, it gives ZnO plus H2O plus 2E, and cathode HgO plus H2O plus 2E gives rise to Hg plus 2OH. So in the overall cell reaction, no ions are taking part. Hence, this cell what, never dead, but it cannot be recharged. So this cell never dead, and its potential difference is around 1.33 or 1.35 volt. Clear now? Okay. So here in the button cell, size is very small. Where we can use in video game, in hearing aids. Yes or no? Similarly, different types of weight machine, calculators. But this type of cells are used in what? In a remote battery. Yes or no? Then watch battery. Then torch light. Clear now? But both are what? Both are not rechargeable. Hence, these are called a primary cell. Clear now? Okay. Then second one is, what is secondary cell? Secondary cell means which can be used again and again or which can be rechargeable. Okay. So next is secondary battery. Okay. Secondary battery, or which one is rechargeable. So in the secondary battery, first we will read lead storage battery, lead storage battery, and another one is nickel cadmium battery. Which one is used actually in what? Earlier in camera. Lead storage battery, and another one is nickel cadmium battery. Okay. So in the secondary battery, so lead storage battery and another one is what? Nickel cadmium battery. So in lead storage battery, you know that battery which one is used in car battery, inverter battery, yes or no? So secondary battery are rechargeable. It can be means suppose current is there, means there what electricity converted into chemical energy, means electrical energy converted into chemical energy, recharging takes place. When suddenly what due to power cut, what generator, or we can say what that inverter, it converts chemical energy into electrical energy. So in the lead storage battery, you will remember lead Pb act as anode and a grid of PbO2 act as cathode. Okay, outside grid, you know PbO2 act as a cathode, and you know this Pb is very heavy. That's why this cell or this battery is quite heavy. And inside this, 38% sulfuric acid is used as electrolyte. So in anode, you see anode Pb electrode, it reacts with sulfuric acid, it forms a BBSR plus 2E. That means this reaction takes place at which time? Means chemical energy converted into electrical energy. Cathode also PbO2, means grid of PbO2, when also it reacts with sulfuric acid, yes or no? It gives rise to PbSO4 plus 2H2O. So the overall reaction is Pb solid plus PbO2 gives rise to 2H2SO4, sorry, plus 2H2SO4 gives rise to 2PbSO4 plus 2H2O. Clear now? So here you see the lead storage battery, this is rechargeable. So when suddenly the current will come, the reverse reaction takes place. Means during recharging, PbSO4, yes or no, it undergoes decomposition, it gives rise to again Pb, PbO2 and sulfuric acid. So you are thinking, or you can ask one question like this, sir, if this reaction is completely reversible, why, sir, after around 4 months or 6 months, why we are putting distilled water inside the battery? Yes or no? Because you see, if the same reaction is reversed, means 2PbSO4 plus 2H2O, it gives rise to Pb plus PbO2 plus 2H2SO4. So if the same reaction is reversed, so where this water go? Actually, these reactions are exothermic in nature, so that's why some waters are evaporated. You have seen in the battery, yes or no? Some caps are there. So inside this cap, in the middle part, you have seen some holes, or small holes are there. Yes or no? So in these holes are actually water. In this reaction, some heat is generated. So due to this heat generated part, some water part is evaporated. So that's why time to time we are using distilled water. Clear now? So what is the advantage? The advantage is it can be rechargeable. Yes or no? So this type of batteries are available in variety form. Suppose your scooty battery or bike battery around 6 volt. So 6 volt means 4 cell we are connected. The 4 cell means in a lead storage battery around 1.5 to 2 volt in one cell. So suppose we need 6 volt, around 4 cells are connected in series. Okay, bus battery, suppose a truck battery around 20 volt battery. Yes or no? Inverter battery 12 volt. So that's why depending on the volt or water, yes or no, more than one cells we are connected. Clear now? But its disadvantage part is only part, it is quite heavy. But another part is second type of battery, which is called a nickel cadmium battery. So in the nickel cadmium battery, yes or no, earlier actually this battery we are using in camera, but now we are not using this because now camera batteries are lithium ion battery. Yes or no? So these battery are quite expensive. Okay, why? Because cadmium metal itself, it is a expensive metal. So here cadmium act as anode, hydrated nickel oxide act as cathode, and potassium hydroxide act as electrolyte. Clear? And anode reaction is cadmium solid plus 2H minus, it gives rise to cadmium hydroxide plus 2E. Cathode nickel oxide H2O gives rise to nickel hydroxide plus 2H minus. Yes or no? So again, this reaction is also rechargeable. Means this cell is rechargeable. Reaction become reversed. Okay, so the nickel cadmium battery is why it is expensive? Because cadmium metal itself it is a costly metal. Clear now? So this nickel cadmium battery it is also very small, so it can be used where? In camera, video games also. So these two are which cell? These two are secondary cell or secondary battery which can be recharged by again and again. Clear now? Okay. So next is fuel cell. Okay, so in this cell, chemical energy directly converts into electrical energy. Okay, so this is one example of also galvanic cell. So here fuels like hydrogen, methane, methanol can be used. Here concentrated NaOH is used as electrolyte. Okay, and in fuel cell you will remember like this. In fuel cell, suppose this is the container. Okay, here the porous graphite electrode. Okay, inside this is medium is sodium hydroxide. From left side hydrogen gas and from right side O2 gas is water. O2 gas is passed and it produces large amount of electricity. Clear? So anode is hydrogen medium OH minus gives rise to water plus electron. At cathode oxygen gas water gives rise to 4H minus, and overall cell reaction is 2H2 plus O2 gives rise to 2H2O liquid. You see, very interesting. Hydrogen oxygen gives water and it produces large amount of electricity, and you see it is a cleaner fuel. Means this cell does not pollute air, so it is a best fuel. And you know this type of cells are mainly used where? These are very expensive and these are used in Apollo space program for spacecraft. Apollo space program. Clear? So here you will remember again I am telling. So in fuel cell, chemical energy is converted into electrical energy. Which type of fuels we are using? Hydrogen, methane and methanol. Which one is act as electrolyte? Concentrated NaOH is used as electrolyte. Anode reaction, cathode reaction. So in the overall cell reaction, hydrogen combined with oxygen gives rise to water. Clear? So this cell runs continuously when we are giving hydrogen and oxygen and produces enormous amount of energy, enormous amount of electricity. Okay, so that's why due to this reason, yes or no, this is used in the Apollo spacecraft, and mainly its efficiency, if you compare between thermal power plant and fuel cell, thermal power plant and fuel cell efficiency is 70%. Fuel cell efficiency is 70%, whereas thermal power plant, its efficiency is around 40%. Clear? And it is a better fuel, a better cell. Why? Because it does not pollute air. It is a cleaner fuel cell. Clear? So this is called a fuel cell. Then next part or the last part, which is called a corrosion. Sir, why corrosion is given here? So in our book one question is prove that corrosion is also one example of a galvanic cell. And we know what is the meaning of corrosion? Corrosion means eating or decaying of metals in the presence of certain chemicals or by certain gases. Yes or no? Decaying of a metal takes place, which is known as corrosion. So here we have taken one example, that is rusting of iron. Rusting of iron. So we have to prove that rusting of iron is a electrochemical cell, and last year some scientists in China they discovered one instrument that during this corrosion, we can produce how much amount of electricity and how can you store this also electricity. You see, anode reaction is iron metal, yes or no, Fe2 plus 4e, so its inert value is this much, minus 0.44 volt. At cathode, this oxygen gas from air, H plus aqueous, it become 2H2 liquid, its inert value is 1.23. So overall cell reaction is iron 4H plus O2 gas gives rise to 2Fe2 plus water. Main part is its inert cell. So you see, inert cell equals to, you know, inert cathode minus inert anode. So cathode is 1.23, anode is minus 0.44. So it is 1.6 volt. You see, that means during corrosion 1.67 volt potential developed. So that's why these scientists, they discovered what certain machine or certain what electrical what your machine where we can what store energy during this what corrosion. Okay, so one question is, sir, where this H plus came? O2 we know this is from atmosphere, but where this H plus? So actually it is believed that H plus is from carbonic acid. That means we know lot of carbon dioxide is present in air. Yes or no? So when this carbon dioxide combines with water, it forms a carbonic acid. So that's why that H plus is believed from carbonic acid, actually that H plus came. Okay, so corrosion is faster in acidic medium and corrosion is very slow in basic medium. You see, yes or no? So you will remember, again I am telling. So what is corrosion? Corrosion means eating or decaying of metals. Okay, here we have taken one example of rusting of iron. Iron is anode, at cathode oxygen plus 4H plus, yes or no? After gaining electron, then it become water liquid. So in the overall cell reaction, the inert cell value is 1.67 volt. Yes or no? Hence it is an electrochemical phenomenon. Where the H plus came? H plus is believed to available from carbonic acid, which can be formulated due to the dissolution of CO2 from air. Okay. Next, we remember, if the pH value is above 9 to 10, that corrosion never takes place. pH value 9 to 10, corrosion never takes place. If water is saline, saline means what? Salty. If water is saline, it helps in the flow of current in the miniature cell. That means in the water saline medium, you have seen cycle, yes or no, bicycle, motorcycle, fishermen, they are using, when cycle or bicycle, scooty or motorcycle, their rim or their body also what rusted quickly. Why? Now due to saline medium, because around the what sea beach, the medium is saline. Okay, and if the water is saline, then corrosion is faster. And how the corrosion can be protected? Corrosion can be protected by oiling, greasing, by galvanization, by cathodic protection, by using anti-rust solution. Yes or no? So this type of water your method by which corrosion can be prevented. Understood? So these are the concept of electrochemistry. So we'll complete this part. Okay, thank you.